Hello everyone, I am S. Kavita, working as Assistant Professor at Kamaraj College of Engineering and Technology. In this video, we are going to see about signal flow graphs. Signal flow graph is one of the topic in control system which mainly used in control system for understanding, analyzing and optimizing the system behavior through a graphical representation. It is a main tool to analyze the complex control system. The method is proposed by Samuel Jefferson Mason, and it is a network which consists of nodes and it is directed by branches. It depicts the signal flow from one end to the another, and it gives the relationship among the signals. So in order to study about signal flow graph, first we need to study about the basic things. Let us start from a simple equation which is having y as an output, and it is a is a scalar which is multiplied with the input x. So for the given expression, we are drawing it as a graphical form. Point is called as a node. There are two nodes, one is an input node and another is an output node, where the signal travels from the starting node to the ending node. So every graph consists of a node as well as a branches. The branches is unidirectional. The flow of signal is represented in the arrowhead. So now consider the two equations where a11 is multiplied with x1 and a12 is multiplied with x2 plus r1 equal to the x1. Here x1 is the output signal and r1 is the input signal. This expression is a21 into x1 plus a22 into x2 plus r2 equal to x2. Here this is the graphical representation of the given expression, where r1 is an input which is multiplied with a scalar 1, where x1 is treated as an output, and once again it is feedbacked as an input to a a1. So x1 signal and it is multiplied with a1. Similarly for the next expression, a12 is multiplied with x2. So x2 is another node. It is multiplied with the scaling signal a12 and it is given back to the x1. So summing is done in the particular node. So this is how the equations is converted into a signal flow graph basically. And now consider this. Here it consists of totally 5 nodes, x0, x1, x2, x3 and x4, total of 5 nodes, and each node is carried away with the signal, that is from node x0 to x1 which is multiplied with a, and x1 to x2 is multiplied with d, x2 to x3 is multiplied with g, and x3 to x4 is multiplied with the signal h. And this is so called as a loop, and this is a forward loop, and this is a feedback loop. So the arrow indicates the flow of signal. Here we can see that the signal is transferred from 0 to x4, and here the E signal is transferring from x3 to x2. Here the F is transferring from x0 to x3. From this graph we can say that x0 is the input node and x4 is the output node, and we can write the expression. X0 is the input node, so it is a signal where it is a starting point where the signals is flowing from the end, and we have to focus on the nodes 1, 2, 3, 4. First node is x1. x1 is a node. In this point totally 3 signals are flowing to it. First one, the signal from a1 and the signal from b1 and the signal from c. So here the a signal is coming from the node x0, so we have to write it as a into the node x0. Next the point should be added together. So b is a self repeating loop, that is b into the node itself, it has to be multiplied, and the third one is c, which is multiplied with the node x2. Similarly we have to write for x2 and x3 as well as x4. We no need to write for the x0 as it is the input node. x2, look at the x2 node. We have to focus on the input signal. One is d into x1 and another signal, incoming signal is e into x3. So by looking on the diagram we have to write d into x1 and then e into x3. Similarly for the x3 node we have to focus on the incoming signal. The incoming signal here we have to focus is 2 signals, that is one is from x2 and another one is from x0. So the 2 signals is g into x2 and another one is f into x naught. And last but not the least one is an output node. Output node is having only one signal, that is multiplied with the node x3. So this is how we are writing the expression for each individual node in the signal flow graph models. Next, the terminologies is the most important thing. We have to focus on the signal flow graph. First thing we do is an input node. What is an input node? It is a source. It only contains the outgoing branches. Look at the diagram. X1 is the input node where the signal is flowing to all the remaining outgoing branches. Similarly, output node is only one node that where all the incoming branches are summing together. X4 is the output node. And what is a path? Path is a continuous and unidirectional succession of branches along which no node is passed more than once. All the nodes should pass it only once. Look at the path. How many paths are there? Here there is a path starting from x1 to x2, x3 as well as x4. So starting from the input node and it should reach the output node, and one node should be travelled once. And second one is x1, x2. Look at the diagram. There is a travel from x2 to x4. So these two are the path. And third and the fourth terminology is a forward path. Forward path is starting from the input node and to the output node. So a forward path, here we have obtained one path is x1, x2, x3, x4, and the another path is x1, x2, x4. So these two are the forward paths, that is one node is travel once and it never ever return back again. And next one is a feedback path or a feedback loop which originates and terminates on the same node. So what is called as a feedback? A path that starts from it and ends it. So for this node we have to look at here, the feedback is starting from x2 to x3 and then it comes again back to x2. So this is a feedback path. So a self loop is a feedback loop consisting of single branch, that is it starts itself and it ends itself. In this diagram, look on it, we are having A33. A33 is the self loop. And gain, what is a gain? It is the transmission function of that particular branch. Path gain is the product of branch gain encountered in a traversing path. So when we are traveling the path from x1 to x2 to x3 to x4, we have to multiply all the gains, the signals that is summing in the branch. So forward path gain of x1, x2, x3, x4. We have to travel from x1 to x4. In between we are having two nodes, that is x2 as well as x3, which is multiplied with a signal a21, here a32, and last one is a43. Path gain is a21 is gain, a32 and then a43. Path as path P1, this is the first path. So I am multiplying the gains a21, a32 and then a43. So this path gain. Similarly loop gain x2 to x3, right? Starting from the node x2 and it reached the node x3 and then it is feedback again to the node x2. The gain is x2 to x3 is a32 and here it is a23. So the loop gain is, the loop gain L1 is written as a21, a23 into a32. So this is the loop gain for the particular loop. So this is the basic things we have found out. And another one is two loops, path loop or non-touching loop. It is if a path we have considered, the loop does not touch the loop. Example, when we are considering the point x3, it is a self loop but it touches the loop of x2 to x3. This is called as a touching loop. Assume this is a sample case. Here 6 nodes is employed starting from x1 to x6. Here we are having a forward path, okay, from x4. It is a forward path only, so no need to worry about the loop. Here the loop is occur at x3 as well as the loop is occur at x4 as well as x5. These two loops is so called as a non-touching loop, where here the loop is touching in the common node. So this is about the touching loop as well as the non-touching. Now come to the main thing, that is Masons. How the Mason simplifies the complex control problem into a simple. With the help of the Mason's gain, we have to find systems transfer function. What is the systems transfer function? C of S divided by R of S. This is the transfer function is output divided by input. We have to implement the Mason's rule. The Mason's rule is output divided by input equal to the formula, that is summation I equal to 1 to n pi into del I divided by del. So this is the Mason's formula. What does the n indicates? Means n indicates the number of forward paths. From the given problem, we have analyzed the how many forward paths is possible. So the forward path decides the number of summations we have to do, and P indicates the forward paths gain. So if there is a 3 paths means 3 forward gain will come. If it is a 2 path means 2 forward gain will come. And del is the determinant of the system, and del I indicates the determinant of the particular path, and del is a common signal flow graph characteristic equation we have to find out. So with the help of the Mason's rule, we can able to find out the transfer function of the system. So with this, I am winding up, and in the next video we will see how to solve a signal flow graph problem.